day everyone! Today we'll talk about mechatronics. First, what is mechatronics? Mechatronics is the study of smart machines that combines mechanics, electronics, and computers. It helps machines sense, think, and act automatically. Examples are robots, self-driving cars, and smart home devices. Do you guys wondering what is the role of software and mechatronics and how it interacts with the hardware components? Let me explain. Software is the brain of a mechatronic system. It controls actuators, reads sensor data, and connects all components. It interacts with hardware by receiving data from sensor, deciding actions, sending commands to controllers, and activating actuators.
What are the types of sensors and actuators used in mechatronics? Before we know the types of sensors and actuators, let me define first what a sensor. A sensor is a device that detects changes in the environment like temperature, light, sound, or motion and converts them into electrical signals that our controller can understand. These are the types of sensor. First, we have temperature sensor. A temperature sensor measures heat or cold in the environment. Second, we have light sensor. A light sensor detects the amount of light around an area. And lastly, we have pressure sensor. A pressure sensor measures the force or pressure of gases or liquids. And now, let's move on to the actuator. An actuator is a device in mechatronics and engineering that converts electrical, hydraulic, or pneumatic energy into physical motion. These are the types of actuators. First, we have hydraulic. Hydraulic actuators use pressurized fluid. And second, we have electric actuators. Electric actuators use electricity. And lastly, we have pneumatic actuators. Pneumatic actuators use compressed air. I'm wondering how sensors collect data and actuators take action based on sensor data. But now I know. Sensors collect data by detecting changes in the environment like temperature, light, pressure, or motion and converting these changes into electrical signals. Then actuators use that data to perform actions such as turning on a fan when it's hot, moving a robot arm, or adjusting a valve. In short, sensors sense and actuators act, working together to make smart systems respond automatically. What is the difference between analog signals and digital signals? Analog signals are continuous signals that vary smoothly over time. They can take any value within a range, like the sound of music from a speaker or the light intensity from a lamp. While digital signals are discrete signals that only take specific values, usually represented as 0s and 1s. In short, analog is smooth and continuous. Digital is discrete and exact. Do you guys wondering what is the purpose of signal processing in mechatronics? Signal processing is the method of analyzing, modifying, and interpreting signals collected by sensors in a mechatronic system. Its purpose is to extract useful information, reduce noise, and prepare signals so that actuators and controllers can respond accurately. Let's learn how to convert between digital and analog signals. First, remember, digital signals use 0s and 1s, perfect for computers, while analog signals are continuous waves. To convert analog to digital, we use an ADC. It changes smooth waves into numbers the computer can understand. To convert digital to analog, we use a DAC. It changes digital data back into smooth signals like music from your phone speaker. I will show you the simple control algorithms to perform basic tasks in mechatronic systems. This algorithm turns the heater on when the temperature drops below 25 degrees Celsius and turns it off when it's at or above that temperature. And now I will show a video showing simple mechatronics assembly. Now, let's proceed on how mechatronics technology is used to address specific real-world problems and improve efficiency. Mechatronics technology is used to solve real-world problems by combining mechanical, electronic, and computer systems to create smart and efficient machines. For example, in manufacturing, robots are used to assemble product faster and with fewer errors. In automobiles, sensors and control systems improve safety through features like automatic braking and parking assistance. In healthcare, mechatronic devices such as prosthetic limbs and surgical robots help doctors work more precisely. Overall, mechatronics improve efficiency, accuracy, and safety, making everyday processes faster and more reliable.